Das System Erde, präsentiert von der Deutschen Geologischen Gesellschaft, Geologischen Vereinigung der DGGV. Die Videoreihe wendet sich an alle an geowissenschaftlichen Themen Interessierte, insbesondere Lehrerinnen und Lehrer an Schulen und natürlich Schülerinnen und Schüler. Sämtliche Videos und dazugehörige Webseiten mit Texten, Abbildungen und Vorlagen stehen Bildungseinrichtungen zur freien Nutzung zur Verfügung. Wir hoffen, dass Ihnen diese Videoreihe gefällt und würden uns über Kommentare sehr freuen. Hello everyone, I welcome the viewers of another episode of my video series on the Earth system. This video is about the formation of diverging plate boundaries. I will explain the development of this plate boundary from a continental rift valley to an oceanic spreading zone. And as with all other videos, I would like to point out the opportunity giving me feedback if you have any questions or comments. You will find my email address on the first page of this video or on the website. A rift valley is formed when a plate is stretched, causing the lithosphere to break. This is shown in the two images above. The breakup of a continent and the development of such a rift can be the beginning of a cycle that we call the Wilson cycle. It is named after one of the founders of the plate tectonic theory, John Tuzo Wilson. In short, a Wilson cycle shows the formation, opening and closing of an ocean. In a later video, I will explain more in detail what we mean by a Wilson cycle. A continental rift, as shown here in the two pictures above, from breaking up to sinking into a graben, can result in a wide ocean forming along this valley. It may lead to the opening of an ocean, but it does not have to happen in all cases, as we see, for example, in the Upper Rhine Graben in Germany. The breakup of Europe had already begun there, but then the plate movement directions changed, and today the Upper Rhine Graben is no longer active as a tectonic graben. The East African rift, however, is still active, and I will present it as a good example for an extensional graben formation. We have various models for the process how a graben structure can evolve. For example, a hot mantle flow from below can weaken the lithosphere, creating a weakness zone where a plate can break apart. The two sides of the graben structure then develop approximately symmetrically. Such a symmetrical graben is characterized by volcanoes that are generally found in the central rift axis, as shown in the figure on the left side. Another possibility is that a large oblique fault zone develops along which the continental lithosphere can slip apart. Here, the volcanoes are not found in the rift axis but often far away from it, as indicated in the figure on the right side. In case of the East African rift, an asthenosphere bulge has developed, which has caused the graben to form at this point around 10 million years ago. Most volcanoes, if we look for instance at Alduino Lengai or Virunga, are located in the rift axis. Others, such as Kilimanjaro, are just a little off the axis. We thus define it as a predominantly symmetrical rift system. Some geologists think that the African plate has already completely broken apart along these graben structures and therefore consider the eastern side to be an independent lithospheric plate, which is called the Somali plate. But it's not entirely clear, because the southern continuation of the plate boundary in particular is not really clearly visible to this day. If we imagine that soon, I mean in a few million years, a plate will break away along the rift axis and a new narrow ocean will form in between, it might look like this map on the right side. I simply cut it apart along the rift axis of the western branch of the graben. I could have taken also the eastern branch, but well, I don't know where it finally will go. This is just to imagine what could happen here. Anyway, what we imagine here for the future has already happened in the Red Sea, which is not far away from here. The Red Sea is the best example of a young, recently opened ocean. In the center of the Red Sea, there is a fissure in which real oceanic crust is already being formed, and the two plates, the African and Arabian plates, are drifting away from each other. In the Wilson cycle, which I mentioned earlier, this stage is referred to as the Red Sea stage. And starting from this stage, it's only a matter of time to form a wide ocean. The Atlantic, which today has a width of several thousand kilometers, also began in the same way with a narrow ocean when Africa and South America started to break apart. A spreading zone is forming in the middle of the ocean, which after some time will be characterized by a mid-oceanic ridge. This ridge has a rift graben at its center on the ridge axis. This is also a rift structure, very similar to a continental rift valley with graben shoulders and marginal faults. Some rift graben, such as the rift zone of the mid-Atlantic ridge, have a very distinct morphology. More or less vertical walls of 1,000 meters height have been found on the edge of the graben. Other rift graben are far less deeply incised, such as the ridge in the Eastern Pacific. As I will show in another video, this is related to the spreading velocity. At slow spreading rates, deep graben structures develop. At fast spreading rates, they remain rather shallow. In conclusion, we can say that a spreading zone with a rift graben develops from a continental rift system. After all, the continental rift is also called a rift graben. However, not every continental rift ultimately results in a spreading zone, but every spreading zone has a rift graben at its center. The spreading zone is a divergent plate boundary. That means two lithospheric plates move away from each other, as shown by the white arrows in the figure. The fissure in the spreading zone reopens again and again and is continuously sealed with magmatic melt that penetrates from below from the asthenosphere. The uprising magma forms the oceanic crust that is formed at the spreading zone in its final thickness. In the next video, I will continue to explain diverging plate margins, focusing on the difference between the formation of new oceanic crust and new lithospheric mantle. Both together result in the oceanic lithosphere, which drifts away from the spreading center. And I will explain what consequences this has for a major ocean. This time, thank you for listening, and I'll be happy if you stick around. I recommend continuing with the video on the formation of the lithosphere.